Welcome to the Idaho State Department of Agriculture Pesticide Math presentation. In this presentation, we will be covering the following concepts: units of measuring, how to calculate surface area, pesticide math formulas, and pesticide math problems. Before we begin, it is recommended that you have a paper, pencil, and calculator readily available. Units for measuring. Pesticide applicators are responsible for making accurate pesticide applications. To ensure an applicator is following the product label rate, the applicator must be able to calculate the treatment area size, calibrate their equipment, and mix and load the proper amount of concentrate material. These activities require using and converting different measuring units. It is recommended that applicators become familiar with these measuring units and their relationship with one another. This is a conversion table. To use this conversion table, multiply the number on the left-hand column by the conversion factor in the center column. This converts your original number to the units on the right-hand column. For example, 1 gallon equals how many ounces? Based on the chart, we take 1 gallon multiplied by the conversion factor of 128 will give us 128 fluid ounces. Or we could take acres. How many acres are in square feet? 1 acre is equivalent to 43,560 square feet. We'll look back on this conversion table as we get into math problems later on. On this slide, we'll go through a few practice problems. 1. How many quarts are in 320 ounces? Based on the conversion chart, we need to multiply our ounces by a factor of 0.031 in order to convert it to quarts. So let's go ahead and do that now. 320 ounces multiplied by our conversion factor of 0.031 is equal to 10 quarts. How about a second problem? How many acres are in 175,500 square feet? Based on the conversion chart, we need to multiply our acres by 43,560 to convert it into square feet. However, the question is asking us to convert the square feet into acres. Therefore, we must divide instead of multiplying. Let's go ahead and demonstrate that now. 1 acre is equal to 43,560 square feet. Therefore, we can take our initial number, 175,500 square feet, and divide it by the conversion factor of 43,560, which is equal to 1 acre, gives us an answer of 4.02 acres. Now it's your turn to solve some problems. For these next couple of problems, go ahead and pause the video and see if you could figure out the answer yourself. If you're unable to figure out the answer, that's okay. Go ahead and resume the video and we'll show a step-by-step of how to solve the problems. How many cups are in 72 ounces? Go ahead and pause the video now. Based on our conversion table chart, 1 cup is equal to 8 ounces. Therefore, our initial number, 72 ounces, can be divided by 8 ounces, or in this case 1 cup, which will give us 9 cups. So we could say that 72 ounces is equivalent to 9 cups. How about another practice problem? How many square feet are in 3.5 acres? Go ahead and pause the video and see if you can figure this one out. Based on the conversion table chart, it looks like we need to multiply our acres by 43,560 in order to convert it to square feet. So let's go ahead and do that. 1 acre is equal to 43,560, and our question is asking how many are in 3.5 acres. So 3.5 acres multiplied by the conversion factor of 43,560 square feet gives us an answer of 152,460 square feet. Let's go ahead and do a few more practice problems. How many feet are in 2.75 miles? Looking at the conversion table chart, we see that 1 mile is equal to 5,280 feet. Therefore, we can take our initial number of 2.75 miles and multiply by our conversion factor of 5,280, which gives us 14,520 feet. Therefore, 2.75 miles is equal to 14,520 feet. Here's another question. How many miles are in 3,875 feet? Before we do any math calculations, I want to point out that 3,875 feet is less than 5,280. Therefore, our answer should be less than 1 mile. Let's go ahead and do this. 3,875 divided by 5,280, or 1 mile, is equal to 0.73 miles, which is less than 1 mile and is what we expected. 950 ounces is equal to A, 9 gallons and 3 quarts, B, 8 gallons and 4 pints, or C, 7 gallons, 3 pints, and 6 ounces. When you are faced with a multiple choice question like this, I like to begin with the answer A and work down until I get a correct answer. So, 1 gallon is equal to 128 ounces. Therefore, 128 multiplied by 9 is equal to 1,152 ounces. We know that A is incorrect because our answer is more than what they're asking for. They need to know how much are in 950 ounces, not 1,152. Let's go ahead and try B. 128 multiplied by 8 is equal to 1,024 ounces. Again, we are coming up with too many ounces for the question. Our answer must be C, but let's go ahead and figure it out anyways. 128 ounces multiplied by 7 gives us 896 ounces, with 54 ounces remaining. 1 pint is equal to 16 ounces, therefore 3 times 16 gives us 48 ounces and 6 ounces remaining. Therefore, C, 7 gallons, 3 pints, and 6 ounces is the correct answer. Calculating the surface area. Applicators must determine the treatment area before applying any pesticide. Some shapes are fairly easy to determine the square footage. For squares and rectangles, all we have to do is multiply our length times our width. For triangles, we can use this formula of base times height divided by 2. And for circles, we can use pi, or 3.14, multiplied by the radius squared. Let's go ahead and figure out the square footage for these 3 shapes. Area for square is length times width. Therefore, the length and width are equal in this case. So 25 multiplied by 25 gives us 625 square feet. Pretty simple. Let's go ahead and move on to the triangle. The triangle is base times height divided by 2. We can see that the base is 25 feet and the height is 15 feet. So therefore, 25 times 15 gives us 375, divided by 2 gives us a square footage of 187.5 square feet. Now, to calculate the square foot of a circle, we need to take pi, which is 3.14, and multiply it by the radius squared. Here, the radius is 30 feet. So radius squared would be 30 times 30, which is 900. 900 multiplied by 3.14 pi gives us 2,826 square feet. For these next couple of slides, we'll be working on calculating surface area. Some pesticide applications are made to structures for barrier protection. Common practices for these applications is applying pesticides 3 feet up and 3 feet out. Look at the floor plan of this building. The surface area of this building is 50 feet by 50 feet, which is equal to 2,500 square feet. But remember, this application is not treating the entire surface area. The label directs the applicator to perform a 3 foot by 3 foot barrier. Therefore, we can take 6 feet, which comes from our 3 feet up, 3 feet out, and multiply it by 50 feet, which is the length of the wall, and it gives us 300 square feet. We then multiply that number by 4 because there are 4 walls that we need to treat, and that gives us 1,200 square feet. So our true application size is 1,200 square feet, not 2,500 square feet. Sometimes calculating the surface area requires multiple steps and conversions. For example, Assume you are operating a boom sprayer and you plan to spray a fence line. Your boom sprayer is 20 feet long and you are traveling at a speed of 4 miles an hour. After spraying for 1 hour, you stop. What is the size of the treatment area in acres? We know that the width of the treatment area is 20 feet because of the boom sprayer. We also know that the length is 4 miles because of the speed and length in time. The first step would be to convert the miles into feet. Looking at the conversion table chart, we need to multiply our miles by 5,280 feet. Let's go ahead and do that now. 4 times 5,280 feet is equal to 21,120 feet. Now we can calculate the area. 21,120 multiplied by 20 is equal to 422,400 square feet. Now the last step is to convert the square feet into acres. 422,400 square feet divided by 1 acre, or in this case 43,560, is equal to 9.7 acres. Understanding proportions. Many pesticide math problems can be solved by using proportions or ratios. We often use proportions to solve many simple problems. For example, if 5 people can eat 10 pizza slices, then 10 people can eat 20 slices. The ratio of 5 people to 10 slices is 1 to 2, which is the same for 10 people and 20 slices, 1 to 2. Sometimes the math is easy enough for us to complete in our mind, and other times it's easier to solve the problem by setting up a proportions equation. Proportions equations can be set up like this. A over B is equal C over D. A and C have a relationship where B and D have a relationship. Normally, pesticide math problems will give you 3 out of 4 variables. The answer to the question is found by solving for the unknown variable. For example, you want to apply a herbicide product to a lawn. The product label instructs you to apply 3 ounces per 1,000 square feet. How much product is needed for 4,000 square feet? In this instance, I've color-coded the numbers to reflect on the proportions. 3 ounces is A, 1,000 square feet is B, 4,000 square feet is D. So for this instance, we'll set up the proportions like this. 3 over 1,000 is equal to C over 4,000. The answer to the question is solving for C, the unknown variable, and in this case, the amount of product needed. The first step I like to do when solving proportions is draw a line down the middle. This helps keep things separated and organized. The first step is to cross multiply. We're going to take 4,000 times 3 and 1,000 times C. The second step is to simplify the equation. 4,000 times 3 is 12,000. 1,000 times C is 1,000 C. The third and final step is to solve for the unknown variable, which is C. So to get C by itself, we have to divide by 1,000 to cross out those, and whatever we do to one side, we have to do to the other side. Divide by 1,000. So therefore, C equals 12. The answer is 12 ounces of product are needed to treat 4,000 square feet. Let's go ahead and take another example here. You plan to make an insecticide application. The product label recommends 3.5 ounces per 1,000 square feet. The application site is measured by 305 feet long by 125 feet wide. How much product is needed? First, I like to sketch out the treatment area size. We have the length being at 305 feet and the width being 125 feet. With that, we can calculate the treatment area size. 305 multiplied by 125 gives us 38,125 square feet. Next, we can set up our proportions. So in the problem that it gave us, it said 3.5 ounces or 3.5 ounces is needed per 1,000 square feet. We have the treatment area size being 38,125 feet, but we need to calculate how much product is needed, which is C, the unknown variable. So again, setting up our proportions with drawing a line down the middle, we can solve for this problem. Cross multiply, so 38,125 multiplied by 3.5, and 1000 multiplied by C equals 1000 C. The next step is to simplify the equation, so 3.5 times 38,125 is equal to 133,437.5. Now, we can solve for C by eliminating the 1000 on the right side and dividing by 1000 on the left side. So let's go ahead and do that. Divide by 1000, divide by 1000. 133,437.5 divided by 1000 gives us C equaling 133.4 ounces is needed to treat this application size. Here's one more example. You are contracted to spray a farmer's field. The product label recommends 3.5 quarts per acre. The field is measured at 35,500 square feet. How much product is needed to complete this application? Before we begin any math calculation, we know our answer is going to be less than 3.5 acres. Why? Because the application site is less than 1 acre. Therefore, we need less than 3.5 quarts to complete this application. So, setting up our proportions, 3.5 quarts is needed for 1 acre, which is equal to 43,560 square feet, is equal to C, the unknown variable, over 35,500 square feet. First step is to cross multiply 35,500 square feet multiplied by 3.5 quarts and 43,560 multiplied by C. Next, we need to simplify the equation. 3.5 multiplied by 35,500 is equal to 124,250. On the right, we have 43,560 C. Remember, we need to solve for the unknown variable, in this case, the amount of product needed. And to do that, we need to divide by 43,560 so that they cancel out on the right, and we're left with C, which is equal to 2.85 quarts, which makes sense because our application site is less than 1 acre. Pesticide math formulas. There are a few math formulas that are worth learning to solve pesticide math questions. Gallons per acre can be calculated by taking 43,560 multiplied by the gallons used divided by the length traveled multiplied by the swath width in feet. Broadcast spraying gallons per acre can be calculated by taking the ounces per minute multiplied by 46.4 divided by the nozzle spacing in inches multiplied by the miles per hour. Speed, miles per hour, can be calculated by taking the distance in feet multiplied by 60 divided by the time in seconds multiplied by 88. Acres sprayed per tank can be calculated by taking the gallons in the tank divided by the gallons sprayed per acre. And finally, pounds of pesticide product per acre per tank. This can be calculated by taking the pounds of active ingredient per acre divided by the percent of active ingredient. In these next few slides, we'll take these formulas and put them into practice. What would the application rate be in gallons per acre if 6.5 gallons are used to treat an area 660 feet long by 21.7 feet wide? Here, looking at the formula of how to calculate gallons per acre, we can take 43,560 multiplied by the gallons used, which is in this case 6.5, divided by the length in feet, which is going to be 660 feet, times the swath width, 21.7 feet. Here it is all set up. Now, to simplify this, we're going to take 43,560 times 6.5, and then 660 feet multiplied by 21.7 feet, and come up with 283,140 divided by 14,322. So our final result is 19.76 gallons per acre is the application rate for this scenario. If a 308-foot course is measured and an average of 70 seconds is required to make a pass, what is the ground speed in miles per hour? Remember, drawing it out may simplify the question. We traveled 308 feet and it took us approximately 70 seconds to complete that pass. Looking at the formula for speed, miles per hour can be calculated by taking the distance in feet multiplied by 60 divided by the time in seconds multiplied by 88. So in this case, 308 feet multiplied by 60 over 70 seconds, our average time, multiplied by 88. At the top, we have 18,480 over 6,160. So our speed in miles per hour can be calculated at 3 miles per hour. For this next problem, I'm going to show you how drawing out the scenario might be easier than trying to solve with math equations. Let's take a look at this example. If a pesticide formulation contains 4 pounds of active ingredient per gallon and you want to apply 2 pounds of active ingredient per acre, how many gallons of product are needed to treat 1 acre? So the first thing I'd like to do is to draw a 1 gallon container. Notice how this 1 gallon container contains 4 pounds of active ingredients, but the goal is to apply half the rate, or 2 pounds of active ingredient. So drawing it out, we can see that 2 pounds of active ingredient would only require half a gallon. So the answer to this question is 0.5 gallons are needed to treat 1 acre at a rate of 2 pounds of active ingredient. How many gallons per acre is applied by a spray rig that travels 4 miles per hour, delivers 35 ounces per minute, and has a nozzle spacing of 20 inches? For this type of problem, we can use our formula for calculating broadcast spraying gallons per acre, which is calculated by taking the ounces per minute multiplied by 46.4 divided by the nozzle spacing in inches multiplied by the miles per hour. So let's go ahead and set up this equation. 35 ounces per minute multiplied by 46.4 divided by 20 inches multiplied by 4 miles an hour. To simplify this, we get 1,624 divided by 80, which gives us 20.3 gallons per acre. This will be our final problem. You are making a pesticide application to a crop field. Your sprayer output is 22 gallons per acre and your spray tank holds 450 gallons. Your application rate is 2 quarts per acre, so how much pesticide must be added to each tank for proper application? Is it A, 10 gallons in 1 quart, B, 20 gallons in 2 quarts, C, 40 gallons in 3 quarts, or D, 45 gallons in 2 quarts? The first step in solving this problem is we need to calculate how many acres we can treat off of 1 spray tank. Our spray tank is 450 gallons and our application rate is 22 gallons per acre. When we divide that, we get 20.45 acres. That means on 1 spray tank, we can treat 20.45 acres. The next step is we need to multiply our application rate by our application treatment size. So 20.45 acres multiplied by 2 quarts per acre gives us 40.9 quarts. Our answer are in gallons. So the last step to do here is to convert quarts to gallons. Looking at our conversion table chart, we see that we need to multiply our quarts by a factor of 0.25 in order to calculate per gallons. So let's go ahead and do that now. 40.9 quarts multiplied by 0.25 is equal to 10.23 gallons, or in this case, 10 gallons and nearly 1 full quart. So the answer is A. Pesticide Math Resources. If you are interested in finding more pesticide math information, please visit the following locations: the Idaho Pesticide Applicator Training Manual, University of Idaho Pesticide Math Module, Pesticide Environment Stewardship, or contact the ISDA Certification Training Specialist at 208-332-8606. This concludes the ISDA Pesticide Math presentation. Thank you.